Good day, everyone. So today, we are going to show to you and discuss to you all about electromagnetic waves.
And first, we will show a simple picture which gives us a simple background about electromagnetic wave.
So as you can see here, this is an illustration of an EM wave or electromagnetic wave. So there is a crest here and a crest here. So the distance between the first crest and the succeeding crest is called
the wavelength.
The second part, as what you can see in the illustration, are the red arrows with up and down direction. And that one is called the electric field.
And also, you can see also the blue arrows going perpendicular to the red ones, which is called the magnetic field.
And also, as you can see, there is this arrow that indicates that electromagnetic waves is also called a transverse wave. That means that it moves in only one direction.
Going on, the definition. A wave produced by the acceleration of an electric charge and propagated by the periodic variation of intensities of perpendicular electric and magnetic field. For the history, this picture was known as James Clerk Maxwell.
So about 150 years ago, James Clerk Maxwell, an English scientist, developed a scientific theory to explain electromagnetic waves. He noticed that electrical fields and magnetic fields can couple together to form electromagnetic waves. Neither an electrical field like the static which forms when you rub your feet in the carpet, nor a magnetic field like the one that holds a magnet onto your refrigerator will go anywhere by themselves. But Maxwell discovered that the changing magnetic field will induce a changing electric field and vice versa.
So, an electromagnetic wave exists when the changing magnetic field causes a changing electric field, which then causes another changing magnetic field, and so on forever. Unlike a static field, a wave cannot exist unless it is moving. Once created, an electromagnetic wave will continue on forever unless it is absorbed by matter. So, just like what is said on this paragraph, it shows the connection between magnetic field and electric field, which causes electromagnetic wave.
Going on, here are some facts and interesting things about electromagnetic waves. Did you know that electromagnetic waves are the only types of wave that can travel through empty space?
So unlike any other waves, EM waves can travel in different medium and also in empty space. That's why it is what we call special like that, because from the solar radiation that came from the sun, our own sun, and by everywhere we can have the waves, or we can apply the waves in everything that we might not see it, but we could understand it through the lessons that we're going to discuss.
Next, all electromagnetic waves are transverse and they're not mechanical. So, just like what we said in the first part, showing you the picture of electromagnetic wave, we could say that electromagnetic waves are transverse, or just like what the definition says, it only goes through one direction.
Next one. Infrared wavelengths have just a little bit longer wavelengths than the color red on the visible electromagnetic spectrum.
So later on, we will show you the picture of electromagnetic spectrum, so that you could understand more about electromagnetic waves.
So gamma waves are the most energetic type of wave, and are in the electromagnetic spectrum, because gamma wave have the shortest wavelength, so it has the greatest frequency and also the greatest energy.
Next, ultraviolet waves have just a little bit smaller wavelength than the color violet on the visible electromagnetic spectrum.
And next,
For the last one, microwaves can be used for radar, just like when we are cooking foods.
So just like in your own houses and kitchen, you can see there a microwave which most of us use to reheat again on
Foods.
our food so that we could use it or eat it again. So here is our last topic, the electromagnetic spectrum.
so as we can see here, there is a wavelength, and we can see the colors here, and also we can see the size as we compare it to a thing, and there is a frequency and energy. So as we can see, from this to this is the wavelength from here longer, then become shorter, which means that the longer the wavelength is also the larger the size of the wave, because as we can see, the size here is big enough compared to in this side, and also we can see the frequency and the energy. Here the frequency is lower and here is higher, which is different from this side, because in this we could conclude that the shorter the wavelength, the lesser the energy and the frequency, and also the larger the size of the wavelength, the lesser the frequency of the wave.
So to sum it up,
In radio, your radio captures radio waves emitted by radio stations, bringing your favorite tunes. Radio waves are also emitted by stars and gases in space. So, as what we can observe while listening to the radio, we could conclude that radio waves are connected to our radios because radio waves are emitted to our radio from radio stations, bringing us what we want to hear or bringing us the latest news and happenings around us.
for the microwave, as we all know, microwave is commonly used in our house, but it is also used by astronomers to learn more about galaxies and space structure and that's it.
So in microwave, we could add in that uses is our cell phone, and our microwaves also, because as we can see, microwave is like a better or greater version of a radio wave. So it has a greater frequency compared to the radio waves.
Next, infrared. Night vision goggles pick up the infrared light emitted by our skin and objects with heat. In space, infrared light helps us map the dust between stars. So, as what the astronomers do in their researches, they use infrared to distinguish or determine whether what they see in the research is dust or star, because it might be hard for them to identify whether it is dust or star, because they have similar in other things, but through infrared they are able to identify which one is dust and which one is star.
Visible. Our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible lights.
So invisible light, it is just a common light that we see every day, and it is called visible light because we could see it, or because of this light, we could see everything around us.
Next, ultraviolet. Ultraviolet radiation is emitted by the sun, and the reason skin turns, tans, and burns. Hot objects in space emit UV radiation as well. So, as what we can see on the definition itself, ultraviolet rays emit it's hot in feeling because, as just like the example, the sun, it gives heat in our body, and it is also one of the source of heat in our world.
So in ultraviolet radiation, it is sometimes the reasons of our burns because it is sometimes dangerous, especially in nowadays that our ozone layer is not that thick enough to trap the radiations coming from the sun. So in ultraviolet, there is an emitted UV radiation from our own star.
Another kind of electromagnetic wave is the X-ray. A dentist uses X-rays to image your teeth. An airport security uses them to see through your bag. Hot gases in the universe all emit X-rays. So X-rays is a big help nowadays in our society because X-rays is used in modern technology such as through searching your bags in airports or malls, and then X-raying your body whether you have if you have a disease or something.
So X-ray was used to scan everything around us. It gives us signals whether something is good or bad in everything that is scanned using X-ray.
So for the last, gamma ray. Doctors use gamma ray imaging to see inside your body. The biggest gamma ray generator of all is the universe. So in gamma ray, we could conclude that it is the wave with the shortest wavelength, but with the greatest frequency. So it can be dangerous, but it is also useful, especially in determining or like as we told you a while ago, imaging to see inside your body. So all these types of waves have the disadvantages and the advantages. So it is just, you know, a so-so. So for a conclusion, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray are arranged by their frequency. So from radio wave to gamma ray, the frequency is getting greater. So also in wavelength. So from radio wave to gamma ray, the wavelength is becoming shorter. So next is in the energy. It is also like the frequency, which means that from radio wave to gamma ray, the energy is getting stronger. And for the size of the wavelength from radio wave, it decreases or reduces its size.
So that's it for today.
Thank you.
Thank you for listening.